On this channel, we provide useful programming information with practical code examples. This time, we will cover WebAssembly and TypeScript. We will explain practical and easy-to-understand methods for integrating TypeScript and WebAssembly. Enabling subtitles will make the code descriptions easier to understand. WebAssembly, WASM, is a binary format runtime that runs at near native speed within the browser. By calling wasm from TypeScript, you can efficiently utilize compute-intensive processes and existing native libraries written in C, C++, or Rust. Here, we will explain the basic execution flow of wasm. TypeScript, or the browser, fetches the wasm file, instantiates it, and calls exported functions. 1. Create a wasm binary using AssemblyScript, Rust, C++, or prepare an existing one. 2. Fetch the wasm file in TypeScript, or in the browser, and instantiate it synchronously or asynchronously. 3. Call the exported functions and share memory using WebAssembly memory, if necessary. Next, we will show a basic example of loading a wasm file and calling an exported function. The browser needs to support InstantiateStreaming. The following code is an example of fetching simple wasm from the server and calling the add function. Functions inside wasm are stored in instance exports. Since TypeScript does not receive type information, you need to use @ts-ignore or create your own type definitions. AssemblyScript allows you to write wasm in syntax similar to TypeScript, making it an approachable choice for TypeScript developers. Here, we prepare a simple function, build it into wasm and ts, and call it from TypeScript. By using ASC, the AssemblyScript compiler, you can generate a wasm file and, optionally, a type definition ts file. To try it locally, install AssemblyScript with npm and build it. Here is an example of fetching and calling from the TypeScript side. AssemblyScript requires careful handling of memory models and strings, but is very easy to use for basic numerical calculations. This section explains the workflow of writing wasm in Rust and bridging it with JavaScript or TypeScript using wasm-bindgen. Here, we use a simple Fibonacci function as an example to demonstrate how to import the generated module as an ES module. Export functions from the Rust side using wasm-bindgen. When you build with wasm-pack or the wasm-bindgen CLI, type definitions for TypeScript and JS wrappers are generated, allowing you to directly import them as ESM. On the TypeScript side, import and use the ES module from package. wasm-pack generates JavaScript wrappers and TS type definitions, making it easy to use from TypeScript. Please note that when you specify web for the target option of the wasm-pack command, asynchronous initialization is required. When exchanging large amounts of data with wasm, sharing array buffer for efficient data exchange is important. Here we show an example using AssemblyScript, but the same principle applies with Rust's wasm-bindgen. On the AssemblyScript side, prepare an exported function to write to memory. For example, a function to square each element of an array would look like this. To specify the memory settings used by AssemblyScript, prepare the following asconfig JSON. To call this function, you need to copy the array buffer into the wasm memory space and pass the pointer. Below is an example of using WebAssembly memory in TypeScript to copy data and call the function. Memory buffer is the shared linear memory. Minimizing copies improves processing speed as much as possible. Note also that pointers refer to positions in bytes, while typed arrays are managed by element counts, so be careful not to mix up these differences. Wasm exports are JavaScript objects, so providing type definitions on the TypeScript side will make development easier. Here is a simple example of a type definition file. The following shows the minimal type definition you can create manually as simple ts. Placing this in the type roots of your tsconfig.json or using declare module will enable type checking. wasm-pack conveniently generates ts files automatically, so it's useful to use them. Since wasm modules require I/O, fetching, and compilation, asynchronous initialization is common. However, there is also a pattern where you cache WebAssembly module beforehand and instantiate it synchronously. Below is the basic code structure for initializing WebAssembly asynchronously. In actual projects, this pattern is recommended. Asynchronous initialization makes it easy to flexibly incorporate error handling and lazy loading, making it the most convenient in practical development. Furthermore, the code generated by wasm-pack includes an init API for initialization, so getting used to this flow will help your work go smoothly. Here are some points to keep in mind for significant performance improvements. Please refer to these optimization tips when combining TypeScript and WebAssembly. When function calls are very frequent, the overhead of calling between JavaScript and WASM can become a bottleneck. We recommend batching data and processing it in one go as much as possible. Memory allocation and copying increase processing load. Utilize shared buffers and pointers to minimize these operations. Be careful when handling floating point numbers. In TypeScript, they become the number type, but you can handle them accurately by matching the types on the WASM side. By combining TypeScript and WebAssembly, you can achieve near-native performance in the browser. This is particularly effective for computation-intensive tasks or when you want to leverage existing native assets. This combination is a very powerful option when you want to improve the performance of your web application. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. Thank you for watching. Subscribe to the channel and check out our new videos.